So when you open R Studio, it will come like this. First, you have the console. This is actually R. R console is, this is the actual R which you have downloaded. On top of it, R Studio will build the GUI. So if you can see here, this is the actual R. 2 plus 3 and enter. You can see here the value of pi log of 10. So you can see here, right? This is console. This is the actual R which you have downloaded, right? On top of this is the console. We call it as console and all. You can minimize it. Once you minimize it, you will get the script file. All the 4 boxes can be minimized. All the 4 boxes which you see here, GUI is 4 boxes, right? All 4 boxes are minimizable and all 4 boxes are listen, right? So whenever you start first you need to create a project folder. Like how we establish a working directory in Python, import IO and all. Here it is slightly easy. What you do is click on File, New Project, New Directory, New Project, give a name to the folder and browse and choose a folder or location where you want to save the project and say create project. Now, once you create project, a folder will be created. A folder will be created with .r project file inside it. A folder exclusively will be created with .r project, .rp or .oj. That is the project file. Now, as you start working on the project file, the history file will be added, the data file will be added into the same folder. If you are saving any outputs, everything will be saved into that same folder. If you are putting data or anything, you can put it into that same folder. So this is how we create a project. So first step is you always create a project. Once you create a project, the console will cover the script file. Now you have to minimize the console. Once you minimize the console, you will get the script file. Now this is the script file where you will write your commands and syntax. The execution happens here. Every line must be executed using Control plus Enter. Here it is Control plus Enter. And this environment which you see here is where the data will be stored. Whatever data you are importing will be stored in this environment. Whatever variables you are creating, whatever changes you are doing to data, they will be stored in this environment. And in the bottom, you can see you have this files, plots. Plots is where you will get the graphs. Packages is the libraries. This is very important. Or what are the existing libraries you have? Default libraries will be there, but you can install. We have to install a lot of libraries as we go through the R. R is dependent on libraries. There are a lot of libraries for different functions. So if you want to install the libraries and packages, go to packages and click on install. If you start typing the package name, auto prompt will start and give you the list of packages and you can install it. Similarly, the help. If you have any doubt regarding any function, you can simply type it in help. You will get detailed explanation of that particular function. Here I am talking, you can look at it, bar charts. What is the function? How to use it? What all arguments you have to give? A detailed explanation with examples will be given in the help. Everything will be explained in help with detail with examples and all the things. So this is a 4-window GUI, R Studio, which we use for R. Okay. Now you can also use Jupyter Notebook for R. You can also use Jupyter Notebook for R. Now the same Jupyter Notebook which you are using for Python can also be used for R. But that you have to set up a separate environment in Anaconda and then you have to install R and then you have to do it. At a later stage, I will show you. Once you go to an industry, you will be working with R in Jupyter only. Because why to move between R Studio and all? So you will be moving between Python and R. So the same code which you are executing in Python, similar code you have to execute in R. Code means models or functions or the hypothesis test for statistics. Because in Python, we don't get the complete statistical output. In R, we get pure statistical output. 100%, this is a statistical software. This is not a machine learning software. This is the pure statistical software, which is also used for machine learning. So the output will be comprehensive. The output will be detailed, but not as detailed as SAS. SAS is the benchmark. SAS is the benchmark in statistical computing. SAS gives a lot of output. But what R guys did was they summarized this as outputs to the relevant outputs, which you need for statistical analysis. Remember, this is a statistical software which found application in machine learning. Python is a pure machine learning software which have some functions of statistics. That's all. In industry development side, it's all Python because of ease of implementation. And second thing is not all statistical rules can be followed. If you stick to all statistical rules, you can never build a model. So what my machine learning guys are doing is some of the things they're picking up from statistics, retaining them, and accordingly they're adjusting the models. Okay, till now it is working well, so they are sticking to that process. Okay, so this is the 4-window GUI R Studio which you need to have for running R. Now, if you look at online versions, we have R Studio Cloud. There is a pre-installed R Studio online, R Studio Cloud, which you can access using the Gmail. Same R Studio, which you are seeing here, will be also available online. But the internet required is minimum 10 Mbps for that to run. Similarly, you will find R in Kaggle. Kaggle also has R with Jupyter Notebook interface. Suppose if you want to use GPUs, graphical processing units, you have to go to Kaggle for R, because Google Colab only supports Python. In case of Kaggle, both R and Python are supported for GPUs. GPUs are required for neural networks. Neural networks, they cannot be run on your CPUs. Basic neural network you can run, but the complex networks for facial recognition or image recognition or those things can be run only on graphical processing units, which are available on Kaggle and Colab. Kaggle supports both R and Python. Colab supports only Python. Okay, so this is the basic description of R, and it's 4 windows of R Studio. Now, whenever you start, you have to click on File, New Project. File, New Project, New Directory, New Project, New Directory, New Project, and give a directory name, whatever name you want, you can give. And choose location and click on browse to choose location to save. To save. Okay, so this is the process of creating a new project, new directory, new project, give a name, and then click on browse, choose any of the location where you want, and then create project. Once you create a project, the console will cover it up. You have to minimize the console. Okay, so this is how you create a new project. Now, once you create a new project, a folder will be created. A folder will be created. So I think mine is data. So a folder will be created with .r project file. This is the file you have to always open. There will be history files, data files. Do not click on them. You have to click on the .rprog file. This file is the file which will store all your data, all your previous commands and syntax. Everything will be stored into this project file. And every time you want to use them, you just need to run, except the import data function, because data will always be there. Unlike in Python, where data also has to be imported, here data will be stored in the environment. So you don't need to run the import command, but rest of all other commands you have to run so that you get the outputs. Even outputs are also saved. Model outputs are also saved. So R is more of a statistical interface. So that is where a lot of outputs will be saved. Your new variable creations, those things will be saved. Unlike in Python, you have to run all the cells, then only you will have the output. Here, it's not like that. Everything will be saved in the environment. You run them, you will get them back into the console. The output will be seen in the bottom console. Okay, and every line has to be run with Control plus Enter. Control plus Enter, or you can see the run function here. Okay. Now, like we have the data. First, we worked on Amsterdam's Airbnb is there. We'll use this Amsterdam's Airbnb. So whenever you're importing the file, you have to name it like how we name in Python. Airbnb is equal to. So like I told you, the function-based programming. Read, you type the first three letters, it automatically suggests the autofill. Read.csv. Now, like in Python, every function will have parentheses. Within parentheses, you can give further arguments. File.choose. This is also another function with its own parentheses. Every function will have its own parentheses. Read.csv file.choose. Control enter will open a browser window. It will open a browser window like this. Go to the location of the data where, like my data is in desktop. This is the data. Select it. So once you click on the data, you can see here 5,732 observations of 18 variables. You can click on the table icon, you can see the data. There's a table icon here, right? You can see all the columns or variables of your data view. So read.csv file.choose is a function which will allow you to which opens a browser window. For Windows laptops, you can see in the bottom. If it is not opening here, it can be in the bottom taskbar, or you minimize the R, you will see in the backend. In that, you go to the location, desktop downloads or documents, wherever you have stored the data, go to that location and you will get the data. So if you are looking at the syntax, read.csv is a predefined function for what? No need. Functions we don't give in quotes, no? Character we have to give in double quotes. There, the path it will take automatically. But if you are specifying the path, you have to give it in quotes. If you are specifying the path, it becomes a character, right? You have to, like there also, any character you have to specify in quotes, single or double. So every function has parentheses. Every function has parentheses. So read.csv is a function, file.choose is a function. We are using function within function. So these are all predefined functions which are available in Python in R, just like how we have in Python. So we got the data here. Now same like, and the functions are also similar to Python. Only thing is head Airbnb. Head Airbnb will give you the first 6 rows of data. So in Python, Airbnb dot head outside. Here it is function inside data frame. Function name followed by data frame reference. There data frame dot function name. That is the only difference. Names are also similar. Only thing is that's an outward definition. This is inward definition. That's the only thing. Head Airbnb. Tail Airbnb. You type the first 3 letters, you'll get the. So Airbnb will give you the last 6 rows of data. So first 6 rows, last 6 rows of data. Can give. Head Airbnb, comma 10. First 10 rows. So comma integer, you will get the first 10 rows. You can specify comma and row. Slicing, I'll tell you how to do. Subsetting or slicing, there's a different process. Indexing, we call it. Same like in Python, we have that indexing also. Specific rows or columns, if you want to select, we have indexing. So you can specify if you want more than 6, you can specify it as integer, comma and integer. right? Function name head, data frame reference, comma, and specify the integer value, whatever you want. Then one of the most important is Airbnb, str. Now, str will give you the data structure. So if I scroll slightly upwards, you can see here, data structure is data frame. What is data frame? Data table. By default, rows are observations, columns are variables. The data frame is same like in Excel, default rows are observations and columns are variables. So you can see here data frame. So it is giving you the data structure, complete data structure, how many observations there, how many we will do. It's like info, dot info in Python we have now, similar to that one we have here. And then it also gives you the individual variable data types. Individual variable data types. So if you look at it, you have num, which is decimal, int, and character. Num means decimal. See, int means whole number, and then character is your object data. Float is num. And if you have anything, you have the date time. Date is another format where you get it as date. But this is how the data is described. str will give you complete information. Data structure, how many are observations, how many variables, and individual variables, data types. Individual variables, data types. So str is a very important function to understand what you are dealing with. Call names. Airbnb will give you the name of variables. You can see, right? Name of variables, you get it as call names. Dot columns in Python, right? You can copy paste the variable names. So as you can see, all the variable names are in quotes. Same rule, everything is same. Characters must be in quotes. Only minor differences in the name, how you define your function, right? Function followed by parenthesis, everything is same. So this is the basic functions which we run once we get the data. Airbnb data read.csv file dot close. This will give us the open a browser window. Using the browser window, you can find your data anywhere on your system and you can import it. Now, the fundamental data structure. The fundamental data structure in R is vectors. In Python, we have arrays and list, right? In Python, we have arrays and list. Here we have vectors. Vector starts with small c and parenthesis. And elements are separated by comma. So vector starts with small c followed by parenthesis. Within parenthesis, you'll have elements separated by comma. So what R will do is whatever data you're giving in table format, in the backend, it will break them into vectors. And then it uses those vectors for computational purposes. So the basic data structure is vectors. So the data will be broken into vectors and then vectors are used for processing. Vectors are similar to matrix. Vector is a one-dimensional array. You can create using vectors two-dimensional, which is nothing but a matrix. 2 by 2 matrix or 3 by 3 matrix you can create. So let us say num vector is equal to C of 12, 35, 66, 3, So you can see here num vector. Vector. Similarly, character vector C of A, you can use double quotes or single quotes. You can do output like this, character vectors. So vectors are the fundamental. Like you have arrays and lists, right? You have vectors in R. So constantly you will see the vectors created whenever you do some major change to the data. In the environment, you can see here values section. There are two sections in environment. Data is where the data is in data frame structure. If the data is in vector format, it comes under the values section. If at all you change some structures, you have segregated variables, or you converted the variable types from one type of variable to others, those things you can see in values. If the data is in the form of a table, it will come in the data part. So environment also has a lot of, so as we go on working with different types of data, the environment will get populated with a lot of values. So these are the basic fundamental structures which you need to find in R. Similarly, we have this indexing. Which decimal value? You can give directly here. It added decimal to 1. By adding, I have added decimal to only 1. But if you see the output, it converted the whole vector into num. So it changes it completely to num or float. So indexing or selection of specific rows and columns. So this is also very important. Indexing or specific rows of columns. We have something called character indexing, which is indexing by name. Indexing by name. There are two methods. The first method is data frame name followed by the dollar symbol. Once you put the dollar symbol, it will give you the list of variables. You can choose the variable name or data frame name, square bracket, single quote, all name or variable name. There are two methods for character indexing. Okay. So either you give dollar sign, the moment you insert dollar sign next to the data frame name, you'll get the list of all variables. So here, Airbnb dollar. Okay. The moment you install the dollar, you will get all the variable names you can choose from the list. Okay. So let us add head Airbnb dollar price. You get the price values. Same thing, head Airbnb square bracket single quote price. The name should exactly match. You will get the same output. Dollar and price or single quotes and price. Now, multi-column variable selection. Vector must be used. You have to use vector for multi-variable selection. So head Airbnb square bracket comma C of price comma what other variable we have? Price, number of reviews, room type, room underscore type. See? So if you are giving multiple arguments, you have to give it as vector. Even if you don't give comma, by default, it will take columns only. By default, it will take columns only. So multi-column variable selection using name is where you have to use square bracket for subsetting, and then the multiple column names must be given in the form of a vector. Multiple column names must be given in the form of a vector. Okay, you can give all the names, whatever it is, separated by comma, but the name should be in quotes, single quotes or double quotes. So this is character indexing. For multi-column, you can't use $sign. For multi-column, you have to use square brackets only. Okay, square brackets is a subsetting part or what you call slicing in R. So character indexing, this is your multi-column or multi-variable selection, single variable selection and multi-variable selection. The names must exactly match. The names are case sensitive. That means it has to exactly match. Numeric indexing is indexing by column number, indexing by number. Okay, now how to find the numbers? The count starts from 1. Unlike in Python starts from 0, here it starts from 1. So that is the difference. Now if you click on and if you scroll your to the header and leave your cursor there, you can see the column number and the type. So column 9 is room type, column 10 is price, column 11 is minimum nights, and the range character will give you the thing. So if you are indexing head Airbnb square bracket 10, you will get the price. If you are doing, this is column indexing. This is column indexing, which you need to be. So multi-column, again, you have to give it as vector. Airbnb square bracket C of 9, 10, 11. So multiple arguments must be given in vector form. Multiple arguments must be given in vector form. Right. Now, you can do row indexing also. Airbnb square bracket. If you want only one row, 23, comma after will indicate row selection. Comma after indicates row selection. If you don't give anything, it indicates column selection. Or specifically want to give comma before. Comma before the number is column selection. Comma after is row selection. Now you can see all the output for the row number 23. Suppose if you want multiple row selections, square bracket C of 23, 56, 68, 99, 100, and then comma. I have given independent uneven values as well as a straight value. Sorry, 99 to 110. Right? So 99 to 110 range I have given, and I have given also uneven. Row number 23, row number 56, row number 68. You can give like this. The comma position is very important here. For row selection, the comma position is very, very important. Comma at the end will be for row selection. So here what happens is generally we combine the data for pre-processing and all, right? That's where we use this row selections. We have to split back after the data into train and test backwards. So when you're doing it, you can do for rows. Because in Python, we have two problems. Count starts from 0, outer value will be ignored. That means if you give 10 in Python, it takes only till 9. Here we don't have any problem. If you say 1 colon 10, it will take first row to 10th row. So that slicing of rows in R is not a problem. Slicing of rows in Python is little bit confusion. It starts with 0 first and outer value will be ignored. If you give 10, it will take only 9. Because of that confusion, people splitting of the data will be problematic. That's why we use equal to test, not equal to test like that. You can use that also here in Python, in R also. But also you can directly subset based on the row numbers because there is no such problems here. If you say 1 colon 10, it will take first row to 10th row automatically. No issues with any subset. So this is all about your indexing. So this is your indexing, both for character indexing and numeric indexing, similar to how we do in Python. We constantly need to write, we need to select, subset, rows and all, we need to what you call subset rows based on data type. So we have all those functions available here also. You have to install. Double click and install it. Still not installed? Okay. That admin guy didn't come today, right? Office admin guy didn't come. My pen drive, where it went around. I think my SQL, I think some students, they took my pen drive and they didn't give back. Yeah, otherwise I always have one in my bag. So last week only we installed MySQL in one place. So there I shared the data with a couple of people. That exe file. All right. So this is that indexing which we need to understand. So same thing like what we have in things, the exploratory data analysis, which is the EDA part, which is descriptive statistics. data visualization, and data aggregation or wrangling. So EDA. Okay. For EDA, we have a very interesting function here called summary. Summary Airbnb dollar price. Summary Airbnb dollar price. So what we got? We got the minimum, we got the maximum, first quartile, median or second quartile, mean, third quartile. In Python, we got a standard deviation also. Here we don't get standard deviation. Here standard deviation we have to calculate separately. So minimum, first quartile, median or second quartile, third mean, third quartile, and maximum. This is a summary, basic summary. This is a basic summary which you get in R. The min, the max, the Q1, min, max, Q1, Q2 or median, Q3, and then the mean. These are the things we got. Now, if you want standard deviation, SD, Airbnb, dollar price. This is the standard deviation. Standard deviation of the data. If you want, SD is the standard deviation. Var is for variance, VAR. So we get this information. Now, if you want all the descriptive statistics, we need to install a library called Site. This is for HR and OB guys. We have to install a library called Site. In this library, there is a function called describe. Describe is a function which is available in Site library. Now, first you have to install it. When you're installing, you have to install only one time. That time you need internet because it has to connect to the R server. Then install the library. Once you have installed it, it will be there till you completely update R. Till you completely update R. Completely means, say we are using 4.2. Say R5 version comes, then it will be gone because package also has to be modified, right? Then again you have to reinstall, right? Once you install a library in R, it will be there forever. And every time you want to use that particular function, you have to activate the library using the library command. That is the process. So the describe function provides complete descriptive statistics. Right? Now, there are two methods. You can use the packages, the install button, and you can type PSYCH. Why it is not prompting? Yeah. First one, it automatically prompts, click it and install it. Okay. Or you can use the command which is install.packages, double quotes or single quotes, PSYCH and control enter. Either you can use the install button in the packages and give the package name. You start typing, it will prompt. You can take it from there, or you can use the function called install.packages. Install.packages will install the package. And this has to be done once. For doing installation, you need to have internet access because the packages will be downloaded from the R cloud server. Okay, it has installed. See, the downloaded is done. Now, once you have downloaded, if you want to use the function in that particular package, you have the library function, library site. No need of quotes, simply say library site. Now the library is active. Unless you activate the library, you cannot use the functions within that particular library. Within that functions, if you want to use that specific function in that library, you have to first activate library and then the name of the library. So, like I told you, describe. And you can see here, describe and cite. Library name in the curly brackets. And then you can see the function argument. What all parameters you can give to the argument. So in Python, we don't get like this, but here we have the Python, we have to refer to the documentation separately. Here, once you start typing, the function related arguments, everything, the basic definition, all will be given here automatically. Describe Airbnb $price. Now you can see we got all the descriptive statistics here. We have the number of observations, mean, standard deviation, median, trimmed median. Trimmed median means top 10% you remove. First sort the data in ascending order. Remove top 10%, bottom 10%. On the remaining, you will calculate the median. Similarly, median absolute deviation. X minus mean, no, variance we have that, no, X minus mean also. Here it is median absolute deviation. Min, max, range. Max minus min, skewness, kurtosis, standard error. Standard error is standard deviation divided by square root of number of observations. So all the descriptive statistics that are required. What are those descriptives? Central tendency. It doesn't give quartiles. Only thing described that doesn't give is quartiles. Quartiles you have to get it from summary function. Or I think quartiles also will be given. We have to add here. Quant is equal to null is there, no? We have to add the quartiles. Let me add the function for. So if you go to help, and type describe. Now you can see all the arguments which are there. See? So skewness 2, range is 2, trim 1, quant is equal to null. So what argument we can give for quant is equal to null? See here, we can explain the quantiles. Quant is equal to C of 0.25, 0.75, because we already have median. So we have to add this argument. And IQR is equal to 2 for interquartile range, Q3 minus Q1. So if you want additional arguments like this, you can add comma quant is equal to vector of 0.25, 0.75, which is first quartile and third quartile, because we already have median, which is second quartile. Then IQR is equal to capital T. Capital T represents 2. Capital F represents twice. So if I do it, now you can see, right? First quartile, third quartile, and the interquartile range. So it gives all. The only thing is you have to add those arguments. So describe is a very interesting function within the psych library, which gives you complete descriptive statistics. To use describe, you should have library called psych. Without this, it will not. So central tendency, your dispersion, your asymmetry, and your location. So central tendency is your mean, median, mode. Dispersion is your variance, standard deviation. Asymmetry is skewness, kurtosis. Location is quartiles, percentiles, deciles. That means anything out of 25%, 50%, and 70%. If you want anything else, you can give based on your requirement. So you have this quantile function. Quantile function is there. You have to give the data and then the value between X, what quantile you want, you can give. So quantile Airbnb $price comma 0.80. So 80% is this. Quantile is base package. Quantile is base package. See, if it says stats, it is base package. Base and stats are your basic packages which come default with R. You don't need to install them. So in quantile, you specify the value in decimals. You can give anything. If you want 22%, specific number also. If you want anything other than say 85%, quantile 85th percent quantile is this. So you can specify your quantile. So quantile is for quartiles, and you can specify the location parameter in decimal. 40, 20, 30, your choice, or specific values or numbers. Okay. So, and then base package also doesn't have skewness and kurtosis. Base package does not have skewness and kurtosis. It is there in describe, psych package. So, if you want to use skew, Airbnb dollar price. 25.6182. Skewness. Kurtosis. Airbnb dollar price. See, very high kurtosis and very high skewness. Very, very high kurtosis and very high skewness. We got similar output in describe function also. Right? Yeah. 25.62 and 949. Same thing we get here, which are the rounded values. So if you want to use skewness and kurtosis, you have to activate the library site. In base package, they are not there. Take a break. What happened? No problem. If it is downloading, let it download.